Hello and welcome to another video. In this video we're going to be working on my calendar 2, and it's kind of similar to yesterday's problem, except now there's a slightly different constraint. So yesterday's problem was you can't have a double booking, now you can't have a triple booking, meaning you can't have 3 appointments that overlap. And so an event is a start-end, just like an interval, and your calendar has a calendar, and you can try to add a booking. And if you can, then add it, and if you can't, then return false. So let's walk through kind of how this would work. So this first booking is 10 to 20. So 10 to 20, we can just draw it here. Then the next booking is 50 to 60. And then 10 to 40, so this kind of overlaps with this one. But that's fine because, kind of like this, I guess, because you can have a double, but you can't have a triple. And then 5 through 15 would overlap with both of these, so you can't have that one. So this is the one that's false. 5 through 10 is fine, so 5 through 10 is over here. And then 25 through 55 is fine as well, because that's going to be like here-ish. So the only one that doesn't work is this 5 through 15. Okay. And yeah, so let me see if I have a number line here. But the basic idea is, let's see, probably do, sorta. But the basic idea is we can have bookings represented as lines, and then we just can't have like a triple overlap. So we can't have something like this overlapping like here or something. You can't have a point in time where you have 3 bookings. So that's kind of the idea. Yeah, so actually we can even rewrite this again. So this could be like 0, 10, 20, 30, 40, 50, 60. And then we can redraw these bookings one more time. So 10 to 20 is over here. So you can see like there's no overlap. 50 through 60 is over here, which is fine. 10 through 40 is over here, which is fine. And 5 through 15, though, overlaps like this, and so there's a point where it overlaps. So if you can't put it, then you just ignore it and you move on to the next one. And 5 through 10 works, it doesn't overlap with anything, so we'll just draw it like this. And then, 25 through 55 is here. So basically, yeah. That's how you check. Whenever you put in a booking, you basically go down, is there any point in time that has 3 bookings? And you could do like a merge intervals type thing here, where you could figure out like what intervals overlap once, twice, and so on. But there's kind of like a way better way to do these problems where you have, because imagine like you could do this with a triple booking, I guess, merge intervals, but imagine if you're looking for like 8 bookings in a row or 7 or something. Imagine if this can just be X and you need to work for a number of X. And so you can use another algorithm, and it actually makes a lot of sense. And the algorithm is called the line sweep, and it's used in a lot of harder problems. But the idea is we can basically have all of the starts and ends in some kind of either array or dictionary, or depending on the problem, whatever you want, sorted. And then we can go through them and then do something at those points. So in this case, we want to maintain the number of bookings. So we can say, like, whenever a booking starts, we'll add 1 to the number of bookings we have. And then whenever a booking ends, we'll subtract 1 to the number of bookings we have. And then all we have to do is just check, is there any point in time where we hit whatever bookings we're not allowed? So is there a time where we hit 3 bookings? And so that's basically all there is to it. And in this case, so you can kind of do 2 things. You can either have like a dictionary, or you can have like an array with your start and end times and then the value. But basically the start's going to be a +1 and end's going to be a -1. And then also obviously like at a certain time you can have multiple bookings start or end. So what we're going to maintain is we're just going to maintain a time and a score dictionary. And then we're going to go through all the values and we're just going to add and subtract and see, do we ever have multiple bookings? So let's kind of walk through that solution for this example 1. And the nice thing about this is, so depending on your language, so for a dictionary or a array or something, depending on the language, you can do a few things. In Python, you can look up sorted containers. And then this will give you like a sorted list or a sorted dictionary or a sorted set that has log n, it has log n input and log n lookup times and everything. It basically keeps a sorted list. So like if you have an array and you want to put an element in the middle, that usually takes linear time. But for these sorted containers, it's log n time to do all the operations. And then I think if you're using like C++, I think there's like a sorted set or some other thing. And then in Java, there's a tree map for this problem, which is a sorted dictionary. So your keys are always sorted. Whenever you put in a new key, it's always going to be sorted. And you're going to have log n inserts, log n lookups. And the way it's made, I think, is like a red-black or AVL tree or something. I haven't looked into making those myself. But yeah, basically, you can use these things to do this kind of thing. And these sorted containers are nice whenever you need to maintain a sorted structure and you're putting elements in and out. That's kind of the thing you want to use. Yeah, and I guess technically, yeah, so you can technically use a tree map to have like a sorted list as well. You can just like ignore the value or something, have the value be like true or false or whatever. Or the sorted list or sorted dictionary, depending on what thing you're using. Okay, so let's just walk through how this will work. So basically, whenever we put in a thing, so we're going to add the interval to our dictionary. So we're going to say, we have no dictionary right now, so we're going to say at time 10, we're going to add 1 to our bookings, and at time 20, we'll subtract 1. And then we're just going to go through our values and just do these operations. So we will start at 0, and then we will add 1. And we don't really care about the times. All we have to do is go through the values in order, right? So at 0, we'll add 1, so our booking will be 1. That's not greater than 2, so we can keep going. And then afterwards, we'll subtract 1, and that's 0, and that's not greater than 2, so we're fine. So we were able to go through this whole thing. So if you're able to go through this whole thing, you just save this value and you return true. And then 50, 60. So we're going to update our dictionary. It's going to stay sorted. So at 50, we will add 1, and at 60, we will subtract 1. Once again, go through our values. So our values now are 1, -1, 1, -1. And we will basically just go through all our values and add them all together and see, is there a point in time where we hit greater than 2? So if we go to the first value, we'll have 1, which is not greater than 2. Then we'll have 0 here. Then we'll have 1 here. And then we'll have 0 here. So that's fine. So we can leave these values in as well. And then 10, 40. So 10 we already have. So now 10 will have a value of 2. And we don't have a 40 yet. So let's add that in. So 40. Yeah. So so 40 can have a -1. Because at an end, we remove a booking. Now our values are 2, -1, -1, 1, -1. Yeah. And so now, do we have a problem? So we don't have a problem again, right? Because we're fine. Like, we can basically go through all our values and yeah, like when we add our values together, we can do this as well. Right, so basically, so we'll have a value of 2, or sorry, we won't have a value of 2. Actually, we will have a value of 2, yeah. So we'll have a value of 2, and then, which is not greater than 2, and then when we subtract 1, we'll have 1, and then we subtract 1, we'll have 0, then we'll have 1, then we'll have -1. So at no point did we get over 2, and that was the third interval, so that's going to be here. And then for the fourth interval, 515 is here. Okay. So for the fourth interval, basically we're going to add this in as well. So 515, so at 5, it's going to be here. And then at 15, we will have a -1. And so now our list is 1, 2, -1, -1, -1. I think it's this. 1, 2, 3, 4, 5, 6, 7. Yep. Okay. And so here we'll have a value of 1, which is fine. Then we'll add 2, and then we'll have 3. And 3 is bigger than 2, so we did hit this 3 bookings. So whenever you check all the values, just going straight down, and you did hit 3 bookings, then you need to kind of say like, okay, this doesn't work, and I need to undo the interval I added. So I'm going to save these things, and I'm going to undo these things. So I'm going to get rid of this 5 value that I added, and I'm going to get rid of this 15, because this interval doesn't work. Then we go to the next interval, 5, 10. So once again, 5, a value of 1, 10 has a value of 2, but now it'll have a value of 1 because we are subtracting because we're at an end. So now our array is 1, 1, negative 1, negative 1, 1, 1. Yeah, and this is obviously fine. We're never going to hit greater than 2, so this is fine. So we can leave this return true. And for the last one, 25, 55 is here. So we'll put in 25. I'll just do it over here. So it'll be sorted when we actually do it, but I'll put it here. 55, negative 1. So our numbers now is 1, 1, negative 1, 1, negative 1, 1, negative 1, negative 1. Okay, and so we'll hit a value of 1, then we'll hit a value of 2, then we'll hit a value of 1, then 2, then 1, then 2, then 1, then 0, which is fine. We never hit above 2, so it's fine. So that's kind of the idea of this like line sweep. Is basically we can just go through our starts and ends, and all we care about is our start and end times. We don't have to look at like every value on the number line. The only time it's going to change is the starts and ends. And then whenever there's a start, we increment. Whenever there's an end, we decrement. And then we have some conditions that we look through. Yeah. And the basic thing is, the only difference is we're going to have a sorted dictionary because we want to go through the values in sorted order. And so for a, let's see, I think for a booking here, this will be end time. Yeah, because to insert is login time, but then we have to go through all of our values. Maybe you can do it in login some other way, but in this case, it's going to be end time. And then you can call at most 1,000 bookings, so it'll be like 1,000 times n or something, which is fine. So that's what we're going to do. And yeah, like I said, in other languages, other data structures do these things. Yeah. And you could probably speed this up in some other ways, because basically you're inserting a booking. Yeah, I mean, you could probably do some binary search stuff to speed it up or something. But whatever, this is good enough. Okay, so we're going to make a bookings. And like I said, we're going to use a tree map. So tree map. And this is basically just like a sorted dictionary. Integer bookings. And that's all we need. And then bookings equals new tree map. Okay, and then in the bookings, we're gonna say, and I think you can use all the like hash map stuff in a tree map. So it's just like it uses hash map functions. Let's take a look. So I think we can say like tree map. It's gonna have a put, I think, or not tree map, bookings. It's going to have a put, just like a dictionary. And then here we can use a key. So start. And we can use a getter default. So bookings getter default. Yeah. And then this is going to be start. And then default value be 0. And then we add 1 here. And for the end, we do the same thing, except we subtract. And subtract. Okay, now we need to go through all of our values. We don't care about the keys. So for integer, I think, val in bookings values. Yep. And so basically, we need to maintain like a current or total or something. So we'll have this 0, and then we'll say total plus equals val. And if total is greater than 2, then we can't do this. But what happened was we added our booking here, so we need to basically reverse this. So if this is greater than 2, we need to take this booking out, so we can do... so we don't need to check getter default anymore, because it will always have a value, so we can just do a get now. Get start, and then get end. And then, so start we did +1, now we do a -1. Now we do this. So we could basically reverse what we did here to get rid of that booking. and then we return false. And then if we never hit this total greater than 2, then we're good, and we return true and keep the booking in here. And that should be it, I think. Okay. So yeah, this is a pretty and yeah, I'm not sure about the runtimes. I think if you make like a tree map yourself or something, probably better, but not gonna do that. These data structures are kind of rare, like a tree map or a sorted list, but I would think it's worth learning. I think they're very easy. Like, it's just literally just a sorted dictionary. They're very easy to learn, and they do have use cases. I've seen like a decent amount already, and yeah, just know the runtimes for all these things. Like, an insert is logarithmic, a lookup is logarithmic, and so on. Honestly, I feel like a sorted list in Python is like cheating because it does a lot of stuff like really well, and it's like to write it yourself is actually a pretty advanced data structure. So I try to usually not do it if I can, but then there's use cases where it's like the best by far, and then yeah, I'll probably make it from scratch at some point, but haven't done it yet. Because like I said, it's like a red-black tree or an AVL tree or some kind of balanced tree thing. Okay, so here I can get rid of this. So let's see. So like I said, the book is, to put in a value, is a log n. Curious what this thing says before we go anywhere. Log n for each booking. Yeah, I don't think this is right. Yeah, I definitely don't think this is right, because we're going through all of our values. So to go through all values, like, you're going through every booking, so that has to be linear. So I think it's, so yeah, I guess for the booking function, I guess we'll just say that time for booking function would be the more accurate function. So time for booking is linear. And space. I mean, worst case, all your bookings fit, in which case you'll have linear space as well, right? So as many, I guess, yeah, so this is like a different n, so this is like number of bookings or something, number of time, number of bookings, yeah, whatever, something like this. Yeah, so something of this sort. Okay, hopefully that makes sense, and yeah. And yeah, you can do this using intervals. It's going to be more complicated, so this line sweep thing is kind of useful for harder problems. Definitely do see it for harder problems. This is probably the easiest problem I've seen with it, so yeah. Good to know, pretty easy to... I think it's a pretty thing to understand, like, okay, when things start, I have one more. When things end, I have one less. Makes a lot of sense, pretty intuitive. So hopefully, yeah, it's going to be everything for this one. Hopefully it was helpful. If it was, please like the video and subscribe to the channel. And yeah, as you notice, I'm probably not going to do daily videos, so I'll kind of just like pick and choose, not going to do easy problems. If they're interesting, then I'll do those. Yeah, so thanks for watching.